This question comes to us from the New York State Regents examination for Algebra 2, administered in January 2019. Question 13 deals with the properties of a trigonometric curve. The function f of x equals a times the cosine of the quantity bx plus c is plotted on the graph shown below. What are the values of a, b, and c? Firstly, let's unpack what the question is actually asking by looking where the variables are in relation to the function. A, in front of the cosine function, is talking about the amplitude of the wave. B, as a factor pair with our input, is talking about the frequency of the wave. And lastly, C is talking about vertical shift. Now, seeing as this is a multiple choice question on the test, you could very well just attempt to graph the function 4 different times, substituting each value for a, b, and c provided by each answer choice. But that doesn't build any real understanding, so let's try an approach that allows us to figure this out whenever we encounter a wave such as this one. The easiest component here to start with will be the vertical shift. That's because the value of c will be exactly the distance between y equals 0 and the baseline of this graphed function. By simply identifying the baseline, either visually or by calculating half the difference of y max and y min, we get that the vertical shift has a value of positive 3. Remember, it's 2 away from the max or the min, not the value of 2 we just calculated. From there, the next obvious value to address is the amplitude, as it is directly related to the baseline. So here, a is the distance from the baseline back up to any of those maxima or minima. In this case, we have a distance of 2 for the amplitude. Now, actually asserting the value of a is a little trickier than that, because we do have to consider if the cosine wave had a reflection over a horizontal axis here, or if it looks like the expected cosine wave. We see from the function that there's no horizontal translation, so we can assume that the wave starts at an x value of 0. By tracing out one full wave period here, we see that from this starting point, the cosine wave looks as we expect it to, starting at its maximum, dipping to its minimum halfway through its period, and then back up to its maximum at the end. Since this means that there is no horizontal reflection, it allows us to leave our a value as a positive value. The last bit that we have to address is the frequency. Although frequency is very easy to pick out algebraically, graphically we're going to rely on being able to observe the wave's period, and then we calculate the frequency from that. Even though we already have one full wave cycle highlighted, it might benefit us to move it over just a little bit to avoid some clutter. Conveniently, we can use any full wave to measure the period. It doesn't just have to be the first wave cycle you encounter. Looking at the difference of x values from the end of the cycle to the beginning, here, pi over 2 minus pi over 6, we get that the period of this graph is pi over 3. Recall, frequency then is equal to 2 pi over the period. Substituting pi over 3 in for the period and then remembering that dividing by a fraction is equivalent to multiplying by its reciprocal, we wind up with a frequency value of 6. Finally, we are able to answer this question. A is equal to 2, B is equal to 6, and C is equal to 3.